Hey guys, this is Dr. Callahan with Week 14 Friday with Probstats. I hope you guys are having a wonderful week. So pause the video and answer the following 3 questions. So today we're going to talk about Hamilton's path and circuits, which is kind of like Euler's, but a little bit different. So first thing I want you guys to do is go ahead and read the objectives right there. And then read the description of what it is. Highlight the most important parts. All right, so a path that passes through each vertex of the graph once is called a Hamilton's path. If the Hamilton's path begin and end at the same vertex and passes all other vertices exactly once, it's called a Hamilton's circuit. So let's go ahead and take a look at this. So A, find the Hamilton's path for the graph. So in order to be a Hamilton's path, you have to go through each vertex exactly once. So let's say, for example, I am going to start off with B. So from B, I'm going to go over to A. From A, I'm going to E. From E, I go to D. And then from D, I end with C. And if you look at this, you did touch every single vertex once, okay? But you did start at B and you ended at C. Okay, so there is your Hamilton's path. Now, on the other hand, if I want to go through the Hamilton circuit, I'm going to clear this up so I have another diagram that I can use. For your Hamilton's circuit, remember you have to go through and begin and end at the same vertex in order and pass through all of the vertex exactly once. So with that one, let's still start at B. So I'm going to start at B. So from B, I'm going to go over to A. So B to A to E to D, D to C, and then C back to B. And so as you can see, we started at point B and we also ended at point B. Go ahead and read the next part right here. Okay, so next what I want you guys to do is do A and B. Find a Hamilton's path that began at the vertex E for the graph in this figure, and then also B, find a Hamilton circuit that begins at vertex E. Okay, so then for A, what you can say is we start at E. I'm going to go from E to A to C to F to B to D, then to G. Okay, so I touched all of the vertices. Now for B, you gotta start and begin at the same part. So this one, we started at E, we ended at G. So try B and see if you're able to find the start and end point to be at E, if it's possible. Okay, so here I'm going to start with E, E to A to B, B to G, G to D, D to F, F to C, C to E. So again, you started and ended at point G, and that is the Hamilton circuit. The number of Hamilton circuit in a complete graph is always going to be with n vertices. So how many little dots do you have? And it's represented by n minus 1 factorial. Remember, factorial is when you have to count and multiply in descending order. So for example, if I look at the previous vertex, A, B, C, D, E, F, 1, 2, 3, 4, 5, 6, 7. From the above example, n equals 7 vertices. So if I plug it in here, 7 minus 1 factorial is the same thing as 6 factorial, which means 6 times 5 times 4 times 2 times 1. And grab your calculator. And this is going to give you 720. Okay, so now that we've done that, let's go ahead and go on to example 2. I want you guys to find it if it's 4 vertices, which means n equals 4, 5 vertices, n equals 5, 8 vertices, which is n equals 8, 3 factorial, 4 factorial, 7 factorial, which is going to give me a 6, 24, and 5,040. Now I want you guys to try with these ones here. So pause the video. And your answers here are going to be 2, 120, 3,620, 880. All right, let's go ahead and talk about trips, okay, and traveling salesmen and people problems. Go ahead and read this part. All right, so this is a one-way fare between each of the 4 cities given by the table. And we need to calculate the airfare between each of the cities as shown below. So here, example 3 says, use the weighted graph in the figure, find the cost of the trip for a Hamilton circuit A, B, C, D, and A. All right, so then looking at this table right here. So with A, I'm going from A to B. So from A to B, it is $190. You have it here in this diagram, or you can go from A to B, and then it gives you the amount on the chart as well. Plus the trip from B to D. So B then goes over to D. B, D. That's $155. Plus the trip from D to C. So D, C, that's $179. Plus the last trip from C to A. C to A. So that's $124. Add everything together. What is your grand total? Here it is. All right, I want you guys to do the same thing, except you're going to do the circuits A, C, B, D, A, and go ahead and calculate that. Your answer should be 124, 126, $155, $157, which gives you a total of $562 for your trip. All right, so next what I'll have you guys do is talk about the traveling salesperson's problem. Go ahead and read that. And then let's talk about the example that we have here. It says a sales director who lives in city A, so A is right there, is required to fly to regional office in cities B, C, D, and E. So here's E, here's A, here's B, here's C, and here's D. So you can see a little bit better. The weighted graph shows one-way airfare is given by the figure in 15.45. Use the nearest neighbor method to find the approximate solution. What is the total cost? So we're going to start this off with A over to C. From AC, we're going to go to CB. So the cost for AC, based on your diagram that you used from the previous table, it's $114, I believe. Actually, it's given to you right here as well, $114. Then from here, you're going to go from C to B, which is $116. From CB, we're then going to go to BD, which is $145. From BD, we're going to go over to DE, which is $194. Then from DE, we're going to go to EA, which is $128. So at this point, we hit every single vertex. Which is in the total down to $748. Now, is there an alternative way that you can do this as well? Pause the video, find the alternative method, and then calculate the cost for me. Or actually, for yourself, I should say. Okay, let's go ahead and look at the alternative method here. So for the alternative method, I want to make sure I have a brand new map. So we're going to start to A to C. So from A, I'm going to go all the way down to C. So that's 114. That was the same as before. Plus, instead of going from C to B, I can also go from C to E. And I'm not quite sure why my pen is not working. Come on. Okay, give me 1 second. Let's see if I can find a different pen. C to E, so C goes to E, and that path is going to be $115. Then from CE, we're going to go to ED. So E then goes to D, which is $194. And then from ED, we're going to go to DB, which is $145. And then lastly, we're going to go from B to A, which is going to be $180. And altogether, $748. Both routes are the same, and but the path are a little bit different. All right, you guys, we're gonna move on to the next part after this. So I have something for you guys to practice on the quizzes, which you're gonna go and work on. So looking at this part here, you are going to go to joinmyquiz.com and you're going to type in the code 27101938, and there are 10 questions for you guys. When you're done with that, I want you guys to watch this video. Here is a link. It's about 6 minutes in Hamiltonian circuits and path. And then for your exit ticket, I want you guys to take a look at the 3 diagrams. Does any of the graph have a Hamiltonian circuit or a Hamiltonian path? And that is your exit ticket. Have a wonderful week, you guys. See you next time.